All right, today what we're going to do is we're talking about mass to mass conversions in a reaction. So this is a 4-step process that we're going to do, and I'm here to walk you through with the KISS principles of chemistry. So it is Keep It Simple Student. So I hope you guys find this tutorial helpful, and please feel free to message me if you have additional questions. For our first reaction, what we're going to do is we're going to compare what happens when we start with 22.99 grams of sodium, and we want to find out how many grams of sodium chloride can be produced. In order to do this again, if we looked at our mole map, we have to start with grams of substance A, convert to moles of substance A, then we can go to moles of substance B, and then on to grams of substance B. In this case, since we are going from grams to moles to grams, we're going to have 4 steps. So we're going to need to draw 4 division bars to be able to represent all those steps that we're going to do. So start out with your four division bars. So this is called dimensional analysis. We always start with what we're given first. So in this case, we're given 22.99 grams of Na. We can consider G and Na like a variable, such as X or Y. They're attached to this number, so we cannot get rid of them unless we cancel them out. So first, let's go ahead and go across the top, the numerators. And we want to be able to talk about where we are going. So we know we can go from grams of one substance to moles of the same substance. So we're going to go ahead and put mole of Na on top. Once we're in mole of Na, then we can go ahead and we can convert to mole of what we desire, which is NaCl. So this is where we're going on the top. Again, all the steps that we're doing to convert go along the numerator. And finally, we want to solve for grams of NaCl. So that is going to go on top. Once we establish where we're going, then we use the bottom or the denominator to determine what needs to cancel. So everything on the top left is going to be canceled out on the bottom right at an angle, kitty corner to each other. So we can see here what we're going to do. So since our first number is just the only number, we're going to put that above 1. That maintains its identity. Then we need to put grams of Na below, and then mole of Na below. And then from there, we need to go to moles of NaCl. So you can see in the blue, I've done substance A, and in red, I'm doing substance B. So now we need to go ahead and figure out what goes where. So we can determine how many grams are in 1 mole based on using the periodic table. So in this case, 1 mole of sodium is equivalent to 22.99 grams by looking at the periodic table. So we're going to put that down below. Then we can also look at the sodium chloride, and we know that we have 22.99 grams for Na, and Cl is equal to 35.45 grams. So when we add these up together, we can find out what the mass of sodium chloride is. Once we've added them up together, we find that the mass of sodium chloride is 58.44 grams. So we're going to put that up on top. And this is also equal to 1 mole, so we'll just put 1 below. Now for the next part, we need to determine what is the mole number for sodium chloride to mole of Na. So in this case, this is coming from our mole ratio. So we have 1 mole of Na to every, 2 moles of Na to every 2 moles of NaCl. So we can go ahead and put those numbers here. So the 2 comes down and our other 2 comes down. So we can see that we have a 2-to-2 ratio. In this case, we can multiply all the numerators across, find the product, and then divide by the bottom. Another way that we can look at this is we can look at what cancels out. So 22.99 cancels out, and our 2's cancel out. So really, in the end, what we're getting here is 58.44 grams of NaCl. So our final product here is 58.44 grams of NaCl. Now, it's not always going to equal to this even number in this case because our mole-to-mole ratio here is the same. And so because they're the same, the mass that we get from the periodic table of sodium will equal the mass of sodium chloride on the other side. Let's go ahead and work on another example. In this next example, we're going to start with 48.15 grams of methane, and we want to identify how many grams of water are produced. So before we can start anything, we must make sure that the equation is balanced. In this case, it is already balanced. So we have 1 methane to 3 oxygen gases to produce 1 carbon dioxide and 2 water molecules. So again, we're going to be going from grams to moles to grams. So that means that we're going to have 4 steps. So we're going to start with 4 bars. So we're going to have 1, 2, 3, and 4. So we have 4 equations that we need to do here. So I've gone ahead and I've set up my 4 division bars. Next thing I'm going to do is start with the number that we're given. So we're given 48.15 grams of CH4. So I need to put CH4 here because that identifies what 2 variables are associated with the number 48.15. From grams of CH4, we can go to moles of CH4. So again, we're just going to put that up on top. Then from moles of CH4, we can go to mole of H2O. So again, this is based on going mole to mole ratio. We're just following along the top on the path of where we're going to go. Our final step in our unknown variable is to solve for grams of H2O. So again, this is going to go on top. Once we have these on top, then we start looking at our denominator. And again, whatever is in the top left is going to come down to the bottom right to cancel them out. So we need to get out of grams of CH4, and we need to get out of mole of CH4, and out of mole of H2O. So we go ahead and we fill out the bottom. Now our first number that is our given, we're going to put that over 1 because we're maintaining its identity. Now if I look at this, I can see what cancels out, and we can see that we've set up our equation properly. So now we need to go ahead and plug in our numbers. So again, anytime that we see grams and moles together, we're going to look at the periodic table. So in this case, we're going to use the numbers from the periodic table. Carbon has a mass of 12.01. Hydrogen has a mass of 4.04 when we have 4 of them. Otherwise, 1 is just 1.01. So our value here is going to be equal to 16.05 grams per 1 mole. So we will put 1 up on top. Next, we can look over at water. And oxygen is 16 grams, and hydrogen for 1 is 1.01, so we have 2, so it's 2.02. So the mass of hydrogen and oxygen combined together to make water is 18.02 per 1 mole. Now our final step is to determine our mole-to-mole ratio. So we're going to look up at our periodic table, and we're going to determine that the number in front of hydrogen, oxygen, is for water, number 2. So we will put a 2 up above, and then our number in front of methane, carbon, and hydrogen is a 1. So we'll put a 1 down below. So what we're going to do here is we're going to multiply our numerators on top and divide by the product of our denominator. So we're going to take 48.15 times 1 times 2 and times 18.02. So the product of our numerator is 1735.326 and continues on. We're going to leave that in our calculator. We're not going to do sig figs until the last step. Then we're going to divide by our denominator, which is 16.05.